All right. Welcome back. I'm Dr. Boyd, the chemist, and today our homeschool science lesson number 24 is running water. Running water. And here's what you'll need. You're going to need 2 cups. I just got 2 cups. They actually don't have to be transparent this time, and you could actually use glasses as well. You're going to need some string. I've got some string here, and you're going to need water. You're gonna need some tape, just a little bit of tape. So I got a little roll of tape here. And then food coloring is optional. I'll be using some food coloring, but of course I know a lot of people don't have food coloring just sitting around. So you're gonna need 2 cups, some string, maybe about 6 to 12 inches of string, water, tape, and food coloring, which is optional. And we will get started in about a minute and a half. All right. All right, we're going to go ahead and get started. And I'm Dr. Boyd, the chemist. I am a research chemist at the Naval Research Lab in Washington, D.C. I am still teleworking. And I should point out at the beginning here that I do have to be on a call immediately at 2:30. So we will wrap up with a few minutes to spare today. But I work at the Naval Research Lab. I'm a research chemist focusing on polymer development. But since everybody's on lockdown, I thought I'd be doing this just to help out the parents who are thrust into homeschooling unexpectedly and to help the children out who also are thrust into being at home and away from their school teachers. And these are just some simple science lessons, things that hopefully most of us or a lot of people have the materials at home. Hopefully you can follow along and do them at home. If you cannot, you can go to my website, drboydthechemist.com, or you can go to my YouTube channel, and that's probably the place you really want to go to follow along with some very fun science experiments. I have done 24, this is the 24th lesson. The first 20 are already posted on my YouTube channel, so check it out by going to YouTube and searching for Dr. Boyd, the chemist. Definitely subscribe. Definitely tell other people who may be interested in doing some simple experiments at home. And if you want to follow me on Instagram, you can follow me at science_made simple_LLC. Lastly, I do want to apologize. Yesterday, I was intending to do another live stream. Of course, we're doing this every day at 2 o'clock, but I had some personal matters to take care of, and it took way longer than I expected them to. And so I do apologize for not being on yesterday at 2 o'clock, but I'm back today, and I hope you all enjoy the lesson. So we're talking about running water. And you saw what we're working with here. For each of the lessons, I see the Stargels are here. Good to see you. For each of the lessons, we have discussed safety. Safety is the most important thing that as a researcher, I must pay attention to no matter when I do an experiment. So I always look at what do I need in order to be safe. And so today, you'll note we're only dealing with cups, water, and string. And so for the most part, this is quite safe. You don't have to worry about wearing goggles or eye protection, gloves for your hands, or a lab coat. We don't have to worry about those things today. This is a very safe experiment. And so the next thing I discuss each time, what are we doing? Why are we doing it? And where do we put that? Well, we write that in our lab notebooks. You have your notebook. I have mine. I always have mine. I've already taken notes on what we're doing today and some questions and things that I hope you will benefit from. So, first things first, I will actually explain the experiment off the top, and then I'll ask you a few questions. As I'm setting up to explain it, I do want to ask this question. What should I write in my notebook? What is important for me to write in my notebook? All right. Well, today our experiment is called running water. So you want to call it running water in your notebook. And I will tell you what our topic is. Our topic today is cohesion. Cohesion. That's that word there. Cohesion. It's spelled Cohesion. 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 All right. That's the topic. And our experiment title is running water. Running water. All right. So I'm going to take today a cup, and in this cup, I am going to measure. I'm going to take a piece of tape and put it on the end here, and I'm going to try to get this string all the way in one corner of the bottom of the cup. All right, so that's what I'm going to do. And what I'm trying to measure is how high up I can still do this so you can see everything on camera. All right, so I think I'm going to cut my string to be about this long. So looks like close to a foot of string that I'll be using. All right, so I'm going to take one end of the string, and I'm going to tape it down to a corner inside this cup. And maybe that's too short. Maybe I should have cut a little longer. Let me see. All right, so I'll cut a little bit longer string. In any case, I'm going to take some water, put it in the second cup, and you'll notice I have already dyed my water green. Again, you don't have to dye your water to do today's experiment, but I think it makes it easier to see if I do it that way. So I've dyed my water green. All right. I should mention you will probably want to put some paper towel or a rag or something down because we will spill a little bit of water. That's guaranteed to happen. You shouldn't spill most of it though. So just want to put that disclaimer out there. We will be spilling a little bit of water. Okay, so I almost forgot about that. So let me make sure to have something down so I don't spill water everywhere on my table here. Okay. Now, this piece of string, what you want to do is once you have your water in the second cup, we're going to take our string, and I'm cutting a little bit longer piece of string because I think that was a little too short. All right. So I've got the string. You're going to want to wet your string up by putting it in your water. So your fingers will get a little bit wet here. I'm going to wet this string up. All right. Now what I'm going to do is I'm going to take this string and I'm going to just get all the excess water off of it. So I'm just going to do this. All right. So the string is wet, but I don't have like a lot of excess water on the string. Now I'm going to take my tape. Again, just a little bit of tape. And I'm going to tape one end of the string to the bottom of the empty cup. And I'm trying to aim to have the tape in one side or one corner of that empty cup. All right, not like directly in the middle. And you should see why once we get rolling with this. All right, so this is what it looks like I have here. I have a piece of string taped down to the bottom of the cup. All right, so here are our questions. First question. If I take this cup of water that's has water in it here, and I take this string and I pour water onto this string, will the water go all the way down the string or will it pour onto the table? What do you think? If I take this string and I take the cup and I just tip it over, what will happen? All right. Will the water just pour onto this rag that I have here? Will it run down the string? Will it do both? Will it run mostly down the string but a little bit on the table? Will it run mostly pour mostly onto the table and a little bit onto the string? What do you think? All right, write it down. Write down what you think. That is your hypothesis. That is your hypothesis. Keep that in mind. That word hypothesis, we recall the definition for hypothesis is what? What is it? What is a hypothesis? All right, it is a guess or an idea or a prediction that you can test. And so we're going to test it out. See, we got the Gavins in the house. Oh, you think it's both? All right. Well, there's only one way to find out. Now, I'll do this first one so you don't have to do it. All right. So I'm going to hold this string here. Notice now I have the string straight up. It is not touching the edge of this cup. So let's see what happens. All right, we'll try this again. Oh, did you see that? Look at that. Look at that. It is traveling down the string. You see this? I hope you can see this. As long as I have the water stream landing onto the string, it actually goes all the way down the string. And of course, a little bit spilled because I kept missing the string itself. All right. So did you get that right? What was your hypothesis? Did you think it was just going to spill everywhere? Did you think it would go all the way down the string? Did you think it would go mostly down the string, but partly onto the table? Or mostly onto the table and partly onto the string into the cup? All right. Well, let's try it another way. This time I'm going to, and this is what I would recommend you try. All right. Although you can do what I just did. Hold the string inside this cup, bring it up at an angle. And again, I'm not allowing the string to touch the edge of the cup. All right. So here we go. Look at that. That is pretty cool, huh? Look at this. So literally going right down the string and not going onto my table anywhere. Okay? Let's try it again just for fun. See if I can get this to work another time. And I hope my folks there on Instagram, I hope you're able to see that. I'll do it a little further over because you're maybe a little too close here. Okay, so just to recap before I do this again, I have a string that I have taped to the bottom of this empty cup. All right, the string, I first wet this string up. It is wet, and I kind of squeezed all the excess water off the string. Now I'm going to take this string, hold it to the edge of this cup here, and I'm just going to tip the water, the cup with the water over, making sure not to let the string touch the edge of this cup. And we're going to watch as the water, look at that, just travel straight down that string. You see that? That's what I call running water. It is running right down the string. You can actually do this pretty fast too. I'm tipping this over at a pretty fast rate. Pretty cool. Oh, you gotta admit, that's pretty cool, right? All right, so what has happened here? What occurred? Why was it possible for string to transport water from one cup to another at an angle pretty cleanly? All right, so I spilled some on in the first attempt, but you notice in that second attempt, really all I needed was just to make sure that the water was running onto the string, and as soon as that happens, it doesn't fall onto the table. It actually kind of sticks to the string and continues running. Well, that process, as I mentioned before, the reason this is occurring is because of something called cohesion. Cohesion. Again, that's spelled Cohesion. 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 All right. Well, the key thing that I did early on was wet the string up. I wet the string up. Once I wet that string up, that means that there was H2O or water molecules on the string. Now, when I take more water and I tip it from this cup that I had the water in, that water is searching for other water molecules. If it doesn't find them, it will just fall down onto the table. But because the string was wet and full of water molecules, it was able to find water. Once it finds the water molecules, it kind of just like sticks to them or comes together, right? We say something is cohesive, we say that it comes together or works well together. Well, all the water molecules are working well together now to transport the water from the cup that I had in my hand that was raised above the table into the other cup through by traveling on the surface of that string. All right, and if you were looking pretty close, if you're able to do this at home, you might have noticed that the water's like kind of wrapping around the string too. So it's not like it's just on one edge of it or one side of it. It's like wrapping around. That means that some of the water was sitting on the bottom of the string. And we would think that something hanging on the bottom of the string, you might expect drops would come down. But no, the drops didn't come down. It actually continued on this path all the way to the bottom of the first cup that was initially empty. And that process is called cohesion, where the water molecules find other water molecules and gets together, and now they create a path for all the water molecules to be transported from one cup that had the water initially in it into this empty cup where the string was taped to the bottom. All right, do you have any questions? Do you wonder, is it possible to do this with a really long piece of string or a really thick piece of string? What do you think? All right. Well, I wish I had the time to do that today, but what I will do in the future is I will post a video explaining this, and I'm going to try a really long piece of string, and we're going to try to find out if it is possible to get water to travel from one cup to another cup over a long distance, maybe a meter, maybe 2 meters, maybe 3 meters. I'll give it a try, and I'll record it, and I'll post a video on my YouTube channel so we all can find out whether or not it works. I actually don't know, so it'll be a learning experience for me too. I suspect it will work, but I wonder if there's a limit to how long the chain of water can go before it actually breaks and starts dropping down. I actually don't know. So it'll be interesting to find out. In any case, I hope that you enjoyed the experiment today. Again, definitely check me out on YouTube. My YouTube channel is listed here, Dr. Boyd the Chemist. You can go www.youtube.com/C/Dr. Boyd the Chemist, and I come up, so definitely subscribe there. Also on Instagram, Science Made Simple. I try to post all the experiment ideas that we're going to have there, and I'll be posting other science things on there as well. And I really appreciate you all showing up for the live stream. Again, I apologize for yesterday. I was quite busy. I'm quite busy today too. And I do have a call to get on to right now. So I must go. I'm sorry the experiment was shorter than normal, but I hope you enjoyed it. Hope you learned something, and I will see you later. All right. Take care. Bye.